Section 1.2, Introduction to Integers. Real life situations. Positive numbers. Numbers greater than 0 and are to the right of 0 on a number line and are greater than all positive numbers. Negative numbers. Numbers less than 0 and are to the left of 0 on the number line and are less than all positive numbers. Natural numbers. Numbers that start from 1 and on, i.e. 1, 2, 3. Whole numbers. Numbers that start from 0 and on, i.e. 0, 1, 2, 3. And integer numbers is basically a compilation of all the negative numbers and positive numbers, including 0, which is neither negative nor is it positive. It's just 0. Here we have our first example of how we can apply negative and positive numbers to represent real life situations. Here we have a ship that's being sank by a glacier in reference to the Titanic. Okay, the squiggly line here basically is what you would call ground zero. Okay, the 0 mark. And what that means is you start at 0. Any number above 0 is positive, and any number that's below 0 is negative. So anything above 0 is considered to be above sea level, and anything below 0 is considered to be below sea level. Here we have a temperature gauge, basically. I guess you would call it a thermometer, if you will, barometer, what have you. But it basically is a representation of how we use negative and positive integers to represent temperatures. The further to the right of 0 you are, the greater the temperature, which means the hotter it's getting. The further to the left of 0 you are, the lower the temperature, which means the colder it's getting. Comparing integers using inequality symbols. The first symbol means greater than. The second symbol means less than. The third symbol means greater than or equal to. The fourth symbol means less than or equal to. And a very helpful note here, the mouth of an inequality sign will always open up to the greatest number and will always point to the smallest number. Remember this for future reference. It may come in handy. For example, which symbol makes the statement true? Is it the less than, greater than, or equal to? In this statement, the proper symbol to make this statement true would be the less than. Why? Because -8 is further away from 0 than -4 is. When it comes to negative numbers, the further the number is from 0, the smaller it is. Which symbol makes this statement true? The greater than symbol. Why do we say this? Because when it comes to positive numbers, the further to the right of 0 a number is, the greater the number. And which statement, basically, what symbol makes this statement true? It would be the equal to. Why do we say this? Because -7 is not less than itself, nor is it greater than itself. It's equal to itself. Graphing integers, okay? This is a very simple concept here. All you need to do is basically find these numbers on the number line and put either X, a dot, a box, or what have you at the time to represent the graphing of the numbers. So where is 0? 0 is right here. So therefore, we will find 0 and we will put a point right there. Where is -3? -3 is basically right here. It's to the left of 0. So we will find that number and put a point right there. Where is 2? 2 is to the right of 0. So we will find 2, which is right here. And we will put a point right there. And that's graphing numbers on the number line. Find the absolute value of a number. By definition, the absolute value is the distance a number is from zero on the number line. The absolute value will be denoted by the symbols of two vertical bars, bars that go straight up and down. The absolute value of any number, negative or positive, is always positive unless there's a negative sign on the outside of the absolute value. Please remember this note, that's very important. Note, do not treat the absolute value bars like the parentheses. These are two different operators. First example, the absolute value of positive 5 is positive 5. The absolute value of negative 8 is positive 8. Negative on the outside, the absolute value of positive 3 is negative 3. Why? Notice because of the negative sign on the outside of the absolute value, the 3 stays negative. Negative on the outside, absolute value of negative 2 is negative 2. Once again, notice because of the negative sign on the outside of the absolute value, the negative 2 stays negative. Order of operations. The order of operation, known as PEMDAS, is a guide that helps us to perform specific operations in their proper order so that we result with the correct solution. PEMDAS. P, parenthesis. E, exponent. M, multiplication. D, division. A, addition. S, subtraction. Now be careful when it comes to multiplication and division. Why am I saying this? Because when it comes to those two operations, you don't always multiply before you divide. So I'm stressing that you understand this, that when it comes to multiplication and division, whichever sign was presented first is the operation that must be done first. First example, 2 to the 4th power divided by 2 times 5 minus 2, which is actually a negative 2, beside parentheses 15 combined with the negative 8. According to the order of operation, I'm supposed to do parentheses first. So I'm going to do 15 combined with the negative 8, which are unlike signs, which will give me 7. I still have a parenthesis remaining, so to speak. So therefore, there's a negative 2 beside a 7, which is multiplication. So if I do that, that will give me a negative 14. Next in order, we have exponents, which is 2 to the 4th power, which is shorthand for 2 times itself 4 times. And if you did that, you will get 16. Bring everything else down behind that. Okay. Next in the order, we have division. Why am I dividing first? Because the division sign came before the multiplication sign. So 16 divided by 2 is 8. Bring everything else down behind that. Next we have multiplication, which is 8 times 5, which is 40. And now I'm being asked to combine a positive 40 with a negative 14, which are unlike signs, which means I have to subtract and keep the sign of the larger number, which will give me 26. Now I'm going to say from this point on, you're going to notice the way I pronounce certain numbers as we proceed is different from the way you may have learned them. It's not because you're wrong, it's because that's the way it was taught. Okay? When I'm pronouncing numbers from this point on, it's going to be a direct indicator to let you know that that number belongs to that sign. Here's an example, another example. Sometimes in math, words can be translated to represent an operation symbolically. The following keywords can be translated into specific math operators. See the examples below and check the chart on the next slide. For example, the product of 12 and a number. The keyword in this sentence is the word product. Product means to multiply. So when it says the product of a 12 and a number, that means 12 times x. For example, a number added to 5. What is the key word in this sentence? The key word is added to, which means basically to add. So a number added to 5 means 5 plus x. Keywords and translated meanings. More than means to add. The sum means to add. Greater than means to add. Increase by means to add. Added to means to add. Less than means to subtract. Decrease means to subtract. Difference means to subtract. Subtracted from means to subtract. Subtract means to subtract. Multiply by means to multiply. Multiply means to multiply. Product means to multiply. Times means to time. We use the dot to represent multiplication. We no longer use the x, so to speak, because often at times people confuse the x symbol with the multiplication x symbol. So we use the dot to represent multiplication. Quotient means to divide. Divide means to divide, and divided by means to divide. And a number in mathematics typically is represented by the variable of x, but it really doesn't matter. You could use whatever variable you choose to use at the time, whether it be y, z, n, or a, b, c. Section 1.4, adding integers. Adding integers. When adding numbers, pay very, very, very close attention to the sign on the numbers. The signs will tell you exactly what operation you will be using to evaluate the expression. Note the various rules listed below. When adding numbers with the same signs, keep the common sign and add the numbers. Okay, here we have a positive 8 and a positive 4. That is how you pronounce that. I'm combining a positive 8 with a positive 4, which is a positive 12. Why? Here the 8 is positive, and so is the 4. Therefore, the signs are alike. So add 4 to 8, which is 12, and the 12 will take on the positive sign because both 8 and 4 are positive. Negative 7 is being added to negative 2. Now here, again, I'm focusing directly on the signs of the numbers. Both the 7 and the 2 are negative. Therefore, that will give me a negative 9. Okay? The signs are alike on both numbers. So once again, when adding numbers with the same signs, add and keep the common sign. When adding numbers with unlike signs, subtract and keep the sign of the larger number. For example, here I have a negative 5 being combined with a positive 3. Those are unlike signs. So therefore, I'm going to get a result of negative 2. Why? Once again, the 5 is negative, the 3 is positive, making them unlike signs. Therefore, we subtract 3 from 5, which is 2. The 2 will take on the sign of the larger number. In this case, the larger number is negative 5. Therefore, this is why 2 is negative. Opposites. The opposite of a positive number is a negative number. So a positive 3 becomes a negative 3. Opposite of a negative number is a positive number. Therefore, the opposite of negative 2 is positive 2. Evaluating expressions. Evaluating expressions involves variables and basically the substitution of a number in for that variable. Okay? For example, evaluate 4x positive y for x equals 1 and y equals 2. What you're being asked to do here is to substitute in for x in parentheses the number 1 and substitute in for y the number 2 and perform any arithmetic operations that are necessary. So as you can see, I'm going to substitute in 1 for x and 2 for y. That will look like this. As always, a number that is directly beside a parenthesis is an indicator of multiplication. So 4 times 1 gives you 4. Positive 4 combined with a positive 2 is a positive 6.